Hello, this is Dr. Oz. Today I will solve a transportation problem. This is a simple problem. We could have more origins and more destinations, obviously. In this problem, I have three facilities, production facilities, one Cleveland, one Bedford, one York. And I have four destinations, Boston, Chicago, St. Louis, and Lexington. If I send one product from Cleveland to Boston, it will cost me $3. If I send one product from Bedford to Lexington, it would cost me $3. So this is the cost structure. These are called origin nodes, these are called destination nodes, and these are called costs associated with each arc between the origin and destination nodes. I have limited capacities for each facilities. Cleveland plant has 5,000 units of capacity in next 3 months. Bedford has 6,000. York has 25 units. And in terms of demand, I have 6,000 demand to be satisfied at Boston, 4,000 at Chicago, 2,000 at St. Louis, 1,500 at Lexington. So let's solve this problem. This is a linear program and has three components. One, the objective function. In this case, I'm trying to minimize the cost. All right, I will calculate that value right here. I'll color code my objective function green. Second component here is my decision variables. In this case, decision variables are defined to be number of units shipped from plant I have three of them in this case, to warehouse J. In this case, I have 4 warehouses. All right. So this is a 3x4 matrix, obviously. So I would just copy paste this area right here. It's gonna be easier for me. All right. So I don't know these values, obviously. So I will delete them. Just this cell. And this is a 3x4 matrix. I will highlight yellow. I want Excel solver to calculate these 12 values for me. Okay, so let's talk about the constraints in this model. I have 3 supply constraints and 4 demand constraints, 7, and I had non-negativity constraints. So let's write them down. Let's start with the demand constraints. Again, constraints have 3 components. Left-hand side values should be calculated versus the relationship. Right-hand side values which are given. All right, so Cleveland capacity is given to be 5,000. If I drag it down, capacity for other 2 facilities are here too. And I can use up to these capacities. That's why these are less than or equal to constraints. Left-hand side values should be based on decision variables that I defined here. And all the shipments from Cleveland, which are these 4 cells, should be less than or equal to, when I add them up, 5,000. And these are number of units. I can drag them down. So let's deal with the demand constraints now. I have 4 facilities. Control C, right click, paste special, transpose, click OK. Let's left align these. All right, so let's look at the demands for each of them. Boston, 6,000. Chicago, 4,000. St. Louis, 2,000. Lexington, 1,500. And I have to, in this model, satisfy those demands. So these are equality constraints. And left-hand side values, again, should be based on my decision variables. So all the products that I ship to Boston, which are these 3 cells, should be total to 6,000. So these are all numbers. All the products I ship to Chicago should add up to 4,000. All the numbers, all the shipments that I transfer to St. Louis should add up to 2,000. And all the numbers that products I shipped to Lexington should add up to 1,500. All right. And finally, I will have my non-negativity constraints. In this case, I have 12 decision variables. These yellow cells cannot be negative. So these are my constraints. How many constraints do I have? Let's count it. I have 3 supply side constraints. All right. Let's just do this quickly. I have 4 demand side constraints, 7, and I have 12 non-negativity constraints, so 19. So let's solve this problem. Before solving, though, I need to define my objective, which is minimize cost. It is some product of my coefficients, cost coefficients, comma, my decision variables, which are my shipments, 12 by 12, 3 by 4 metrics each. This is not a matrix multiplication, by the way. This is multiply each of those matrix elements 1 by 1. Perfect. So this is $1. I'm trying to minimize this. All right, so let's solve this problem. Data, solver. If you don't know how to add solver, please watch my previous videos, or you can just Google it. My objective function is right here. I'm trying to minimize this problem. And my decision variables are these yellow cells. Let's add my constraints. Let's add my supply constraints together because they have the same relationships, 3 constraints. This is my right-hand side value. These are my right-hand side values. Click add. And these are my left-hand side values for demand. And these are equality constraints. The right-hand side values are given here. Click OK. And make sure this is checked because my decision variables are non-negative. We are using simplex linear programming and solve. And then if you want to create sensitivity report, click sensitivity, click OK. So Excel solver found the best solution for this model. And the best solution for this model is, let me just quickly fix this. These are shipments. All right, so minimum cost that I will pay is $39,500 for this model if I don't want to violate any of these constraints. As you see here, I use all my capacities. They are all binding constraints. I satisfy all my demands. They are binding constraints as well. And here are my shipments. For example, I will ship 2,500 units from Bedford to Boston, 0 from Bedford to Chicago, and this will give me the minimum cost. That's it for this video. Until next video, enjoy business analytics.